All right, welcome to the Chapter 8 practice test. So going through this will be the key to your success. Get it? Key. So simplifying. I'm not allowed to just cancel anything out I want to. I have to cancel out like factors. So the first step is to factor. Factor, 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 factor. X and X, 2 and 1. Negative 2 and plus 1. Yeah, that'll make the negative 1 in the middle. And then 5 and 1, because 5 and 1 multiplied and then added would be the 6. So we are allowed to cross out the same factors always. So the same thing divided by the same thing is 1. So it's not like it disappears, it just turns into 1. And then we have this left over. So the answer is x minus 2 over x plus 5. Now on this practice test, or the test, I'm not going to ask you to tell me the restrictions. We're going to talk about restrictions when it comes to problem 4, problem 11 on the back here, and then of course the restrictions when we graph, like creating the asymptotes. Okay, so there's the answer for this one. Now this one here is like, math teachers love these problems because you get to do 4 factoring problems all in one problem. Look at all this factoring you get to do, and factoring is fun. So x minus 3, x minus 8, that would make the 24 and the 11. X minus 10 and x minus 8, that would make negative 18 and 80. X minus, lots of minuses here, 10 and then 15 and then 5. And then this was also x minus 4 and x minus 5. So all of those make that up there. Now we can start hacking away. Let me get out my red hacking pen. Boom, boom. Same thing divided by the same thing is 1. They can be above and below each other, or they could be diagonal from each other. It's just the top of the fraction means multiply, the bottom of the fraction means divide. And so if it's on the numerator and the denominator position, either diagonally or straight above and below, you can cancel them out. Boom. This is the only thing that's left. So my answer is x minus 3 over x minus 4. Yes, I believe that deserves a little bit of colorful stuff here. Let's see, where's my color? Oh, here we go. We need to celebrate that answer. Woo! Okay, now we're going to create a common denominator here. So before I just start multiplying these together, I'm going to factor to see what it is that I have. So let me push this up here. So there we go. X and x minus 4 minus 5. I just got that from up here, so it's the same problem. And then minus 5 over x minus 5 and x minus 5. So that's a perfect square deal. So this one here has 2x plus 5s. That one only has 1x plus 5. So this one has 2x plus 5s, and this one only has 1. So I got to have an extra one, don't I? Okay, this one has an x minus 4 and this one doesn't. So this one needs an x minus 4. So we multiply the numerator and the denominator by the same thing, because the same thing divided by the same thing is 1. So I'm not changing the value of the fraction, I'm just changing its appearance. So this would be x minus 5 multiplied by 1 doesn't do much. Now you have to distribute the negative here. So if you want to, you can think of this as plus negative 5. This times that would be negative 5x. This times that would be plus 20. Over x minus 4 times x minus 5 squared. Put the x's together and we get negative 4x. Put the numbers together, we get 15 over x minus 4 times x minus 5 squared. So my rule of thumb usually is to simplify the numerator, leave the denominator factored. That's the most useful way to leave it typically when you get to calculus. We're going to clear out the fraction here. So we're going to multiply by the LCM. So LCM, and everything needs to have an x squared, so that needs to have an x squared, and then everything needs a 2 and a 9. Well, 2 and 9, 18 is the LCM for 2 and 9. So what an LCM is, it's like the common denominator. It's the thing that all of these will divide into. So now we're going to do that division. 9 divides into there, leaving 2 and x squared. 2x squared times 1 is 2x squared. 2x divides into here, leaving 9x, so plus 9x. And then that divides into there, leaving the 18, so equals 18. So I've created a quadratic. Oh, for this I do need to think about the restrictions because I'm solving. And x can definitely not be 0. So x cannot be 0. That would cause a division of 0, which would be an issue. Move the 18 over, so 2x squared plus 9x minus 18 equals 0. And we're going to factor this. Now if it didn't factor, we have to use a quadratic formula or completing the square or something, but this factors. Let's see, if we put the 6 over here opposite, that'd be 12, and then the 3 here. How about positive 12 minus 3? 12 minus 3 is 9, that's it. Now we do 0 product proper t, where we set each factor equal to 0. Add the 3, divide by 2, and we get 3 halves. That doesn't interfere with the puffy cloud. Subtract the 6 over, and we get negative 6. So I call this a puffy cloud because I always make like a little puffy thing around it. Those are my restrictions on this. So restrictions are really important when it comes to solving, because sometimes you can get no solution. Okay, the next page, 5. Number 5, we know that it's an inverse variation, so we multiply these together. So this times this, 3 times 7 is equal to 21. So x times y is equal to k. That's what a direct or inverse variation means. So we know k is equal to 21. So now I can write the formula, x times y equals 21. Then it says find k. So x is 4, 4y is equal to 21. Divide the 4 over, get 21 divided by 4. Which is equal to 5.25, or you could call it 5 1/4, or you could call it the 21/4. Any of these answers are the equivalent to each other. On number 6, you just have to find the equation, and you just write the model here. So z varies jointly, so z is equal to w with a k, connecting them together, w and x, and inversely with y squared. So y squared goes on the bottom. So basically I'm going to plug everything in, find k, and then just rewrite the equation. So it says z is 8, k is k, w it says is 16, so I plug that in, x is 1, so I plug that in, all over y, which is 2. So then, 2 squared, it's 2 squared, so it's going to be 4. Okay, so that's 4 divided into 16 is 4, and then times 1 will be 4. So it's 8 is equal to 4k, because that's supposed to be 4 because it's squared. It's 2 squared. Make the 2 a little bigger there. Okay, so k is equal to 2. Now we write the equation out. Z is equal to 2wx over y squared. And now you can see why I always put a little slash through my z, is because that way it won't look like a 2. Okay, discontinuities. You're not allowed to divide by 0, so we're going to try to figure out what happens here dividing by 0. So we got 4x, and then so I'm factoring this. It'd be x minus 4 equals 0. And then you set each factor equal to 0. And we find discontinuities at x equals 0. That's a discontinuous place, and x equals 4. So those are the 2 places where there's discontinuities. So f of x is discontinuous at x equals 0 and 4. All right. Then we have to go through the whole process of, is it a tie or what is it? So here the exponents are tied, so we use the coefficients. So it's y is equal to 3 over 2. Now when the exponent on the top is smaller than the exponent on the bottom, then we say that it's 0, so y equals 0. And it has to making x go to a large number. So when x becomes really super large, basically this would be like 3 billion over 2 billion. Well, 3 billion divided by 2 billion, because adding 5 or subtracting 3 from a billion really doesn't do anything. So this behaves like 3 billion over 2 billion, which would be 3 over 2. And then if x is really large down here, this is so much bigger than this that is basically, it's like a small number over a huge, huge number, which is like 0. So it has to do with x becoming really large. Okay, now we're going to graph. This is the shifting. This was the h and the k business. There's your h, and then this is k. So it's 2 spaces to the left. So I'll make my vertical asymptote here. So it's 2 spaces to the left, and then 2 spaces up. Okay, now I'm going to pick some points out to figure out where it curves. Since A is positive, we know it curves in here and in here. So I just picked some points out. My first point that I'm picking out, and I'll graph it here. This is x cannot be, or that equals -2. That's your vertical boundary, and then y equals 2 is your horizontal boundary. Plugging in some points. Plugging in -1. So I try and pick points on each side of the vertical boundary here. So I'm going to pick -3. So if I put -3 there, that would be -1. -2 plus 2 is 0. -3. I'm plugging in -3, not -2. So -3, yeah, it would be 0. So -3, 1, 2, 3, 0. So it curves like this in this quadrant there. Now I'm going to pick a point on this side of the vertical asymptote. So I'm going to pick -1, just barely on this side over here. That's going to be 1, 2, 2 plus 2 is 4, so it's -1, 4. So -1 up 4, now I know it curves like this in this space like so. So that's the basic graph. Okay, this here says that x cannot be plus or minus 3, right? Because that would cause division of 0. So that's my 2 vertical boundaries. So -3 and +3. 1, 2, 3. And 1, 2, 3. And then when it's a smaller over a larger, then y equals 0 is your other boundary. So we got x is equal to -3, x is equal to 3, y is equal to 0. Now I put points in. 0 works as an awesome point to put in, because that would be the x and y intercept, because 0 goes in and 0 comes back. Because you put 0 there, it would be 0 over -9, which is 0. So there's 0, 0. Now typically these make a U shape or kind of an S shape, so we're going to see what happens when I put in -2. -2 would be -2 on the top, and it would be 5 on the bottom, so it's -2. No, it's -2 over -5, so it's actually going to be positive. It'd be -2 on the top and -5 on the bottom, so it's positive. So over -2 and up just a little bit. So that means it curves in like so. And then +2 would be 2 on the top and -5 on the bottom. So then it's 2 and then right there. So it curves like this. So this is one of those with an S shape through the center. Okay, now I'm going to pick another number. Like, does it curve here or down here? I'll just try 4. So I'll put in 4. It gives me 4 on the top, and it gives me 16 minus 9, 7 on the bottom. So I go over 4, 1, 2, 3, 4, and up a little bit. So it's going to curve like so in this little quadrant. And then -4 is actually -4 over 7. So -4 down there, so it's going to curve in that little quadrant there. So it curves in here, an S-shapey thing in there, and then it curves right there. So pick some points in the different regions and see how it curves. So I picked the -4, 4 on each side, on the outsides of the vertical asymptotes, and figured out what it was by plugging it 4 in and -4. And then I put some points in to figure out, did it curve like a U shape or a right side up U or an SE thing, or does it go through SE like this? You just got to try points to figure it out. And then you're free to type it in your calculator to make sure that it works. And it kind of makes sense. So when you type in your calculator, make sure you put those extra parentheses there to force the division. Okay, problem on the back side. Woo-wee! This one's crazy. Now, what's nice about this problem is the fact that that this times this is actually this. So if you factor this, you'll see it, x and x minus 2 and minus 10. So this times this is this and that. So we got our LCM like hot on the, we're hot on the trail on our LCM. So puffy cloud, x cannot be 10 and 2. And we're going to have the LCM, and we got x minus 2 and x minus 10 as the LCM. So here we go through the process. We're multiplying by the LCM. So this divides into there, leaving this. So it's going to be this times the 2. So it's 2 times x minus 2 minus 3. This goes into here, leaving that. So it's x minus 10 equals. This whole thing goes in there, leaving 1. 1 times 6 is 6. We basically just created not a quadratic. Like the first page here, this turned into a quadratic. We had to do the factoring or whatever. This is all linear because we don't have any x squareds or anything. So I distribute, piece of cake. Be careful not to forget to distribute the negative. So it's minus 3x plus 30 is equal to 6. Combine like terms, negative x plus 26 is equal to 6. Hang on a second. My wife is calling me. All right, so bring the 6 down. Then we're going to subtract the 26 over. Look at negative x is equal to negative 20. Divide each side by the negative. X is 20. All right, and it doesn't interfere with the puffy cloud business, so x is 20 for all of this mess here. Awesome, done, woohoo.